In our series of video how to run basic OpenCL code, the previous episode covered what is kernel, why, and why are kernel essential for parallel computing, cross-compute device, giving you performance that is impossible with the sequential CPU curve. If you are just joining us, this series is all about breaking down OpenCL concepts into simplest, most innovative way possible, whether you are working on CPU, on GPU workload, or just curious how parallelism works at a deeper level, you are at the right place. Welcome to CompilerSutra. What we are going to cover today. In today's video, we are diving into two fundamental models that are power, energy, OpenCL application, the platform devices, the device model. Even to run a basic kernel, you need to understand how this model works. They help OpenCL discover what hardware is available, set it up, and decide how your code should run across different devices. To make all this easy to follow, I am going to use the simplest relatable example of a food court kitchen. Let's assume you are head chef in charge of huge food court. But here's the thing, you are not cooking anything yourself. You are just managing, you are coordinating the restaurants, assigning the recipes, and make sure the food gets to the customer on time. That is exactly what the host does in OpenCL. Now let us map this kitchen scenarios to OpenCL. The host is you, the head chef or manager. You do not cook, you plan and assign. The platform is restaurant in the food court. Maybe one does South Indian, another does North Indian, and another is just for juices and dessert. These are like different GPU devices of different companies such as Intel, AMD, NVIDIA platform. Command queue is your recipe book. It lists exactly what to make when you give this to each station so they know their role. Instead of one chef preparing 100 customer order one by one, which is sequential, you have 100 cooks, each handling one order at a time. This is parallelism, and that is exactly what OpenCL enables. And well, once all cooking is done, food delivers to the customer. So as the host, you check the output, make sure everything is done correctly, and pass the result along to the customer, or in OpenCL term, collect the result back from the device. So here is the key idea. The kernel is where all real action happens. Everything else, the host, platform, context, command queue, is just preparation and coordination. Let us now understand what the platform model really do. Think of platform model as understanding the kitchen infrastructure. It is like walking into restaurant and figuring out how the kitchen is set up, what equipment is available, how many cooks can work at the same time, and what kind of food they are specialized in. Too much to understand. As a manager, being aware of this setup helps you to make smarter decisions, like which station to assign, how many orders to send, and which tool can be shared across each team. Understand, with a simple example, my favorite dish, paneer. Without proper setup, the kitchen has no idea who will cook the paneer, where will the naan be bagged, in the tandoor or on a pan. Each chef is free to take the task. Where are the ingredient tabs? If none of this in place, the order is just sit somewhere on the sky and will be unprepared, and the rating will go down. How stock markets behave once we listen about the cost. Now, if apply this to the OpenCL, the platform model answer which kitchen. Kitchen here is vendor and platform can handle this. It checks what devices are available, like tandoor as a GPU and a stove as a CPU or a grill as an accelerator. So it set up the context, the shared memory, ingredients, and tool area. Then it prepares command queue and all the instruction list, grill the paneer, bake the naan, then place, or then plate it and give order to customer. So the platform model is all about preparing and organizing the kitchen so that everything is in place to run smoothly and efficiently. The second one is most important, device model. Now that the kitchen is ready, let us talk about how the cooking actually happens. This is where the device model comes. The device model explains how OpenCL take the task and break into smaller steps that run in parallel. Let us take with our example of 100 plate of paneer naan. Instead of asking one chef to do everything, you can break into smaller specialization steps. One chef chop the paneer, another prepare the spice mix, some else kneads the naan dough, Another chef handles the baking in the tandoor. And finally, someone plates everything up. Each chef works on just one part of the order, and they all are working at the same time. That map to OpenCL. A device contains multiple compute units, like the team of chefs. Each compute unit has several processing elements, the actual individual cook. The kernel is the paneer naan recipe, defining the step of the job. OpenCL breaks these into a work item, one for each specific subtask. They are grouped into work groups assigned to the compute unit. That way, the system does not wait for one cook to finish everything. It runs all the steps in parallel using different people as processing elements working on different parts of the same job. This process execution is what makes OpenCL scalable, powerful, whether you are on phone or supercomputer. Quick recap. Let us wrap things up quickly. Summary. What is the platform model? The platform model helps OpenCL discover available hardware, set up the device, and prepare the environment, just like organizing a kitchen before taking order. Device model explains how work is distributed to different parts of the device, like assigning individual specific role and running them in parallel. The host only manages it, but never cooks, like your company manager. He will only give you orders, but he will never cook. The kernel does the actual job, like the recipe being followed by all the chefs. With this model working together, you get high performance parallel execution no matter the hardware.